Quick, graph y equals the greatest integer of the quantity of 3 times x by hand 2 different ways. It is highly recommended that you watch the video How to Graph y equals f of the quantity k times x before watching this video. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during the video. The first way is with what we call the step dance. Normally we start at the origin, and the coefficient of x, 3, inside the brackets does not affect this point. So when x equals 0, the greatest integer of 3 times 0 is still 0. Also recall that the coefficient, k equals 3, is inversely proportional to the horizontal dilation factor. That is, we're going to multiply each x value by the reciprocal of 3, which is 1/3. And the width of each step is also multiplied by 1/3. So instead of being a whole unit wide, it's 1/3 wide. And there's our first point there at 0, 0. Recall that the left point of a step is closed while the right endpoint is open. Normally the next step begins at 1, 1, but for our graph it's going to be right 1/3 up 1, because a third times that 1 is a third. The y value has remained unchanged. So at a third, 1, we will put our next step. Again, the step is about a third of a unit wide. The next step normally is at 2, 2, but ours is going to be right 2/3 up 2, because 2 times a third will be 2/3, the y-coordinate unchanged still. Next step at 3, 3, but ours will be at 3/3 or 1 up 3. And now I think we have enough that we can go ahead and continue the steps using this pattern. As you can see, they're going up. They're also going to go down in the third quadrant, and then a whole bunch of them there. So press pause if you need to catch up. Here we have the parent function plotted, and you can see that it is a horizontal shrink from blue to green. We'd also like to point out that you should notice that the greatest integer of 3 times x is different from 3 times the greatest integer of x. When we did this before, the steps were 3 units apart, and the width was still 1. This is a different 3 altogether. Second way, using a table. We're going to look at the left endpoints, the coordinate pairs for the left endpoints, and these are the 5 points that we're going to use. Since k equals 3 inside the greatest integer brackets, the horizontal dilation factor is the reciprocal of 3, which is 1/3. And we're going to keep the y-coordinates the same, as you can see here, but we're going to multiply each x-coordinate by the reciprocal of k, which is 1/3. So 2 times a third is 2/3. So 2/3, 2 will be our left endpoint. And remember, our step is going to be only a third of a unit wide. 1 times a third is 1/3. The left endpoint is at 1/3, 1. 0 times a third is 0. So at the origin is another step whose width is 1/3. -1 times 1/3, -1/3, -1, and -2/3, -2. We can go ahead and finish the steps, add in a few more, get enough to see the pattern there. It does go on infinitely in both directions. And then we can compare it to the parent function and see that it is a horizontal shrink. Now you try one. Graph y equals the greatest integer of the quantity 2 times x. Use either method or both for the practice. Press pause to do this and then resume when you're finished to check your answer. And here's your answer right here.